Hi everyone, this video we will be discussing about the WA1 of 2020, which is also your milestone check paper. This was the WA1 taken by the primary 5s last year and becomes your practice paper for this year. So we go into question number 1, express 2/25 as a decimal. So there are two ways into doing it. So the easiest way would be to make your denominators into 10, hundreds or thousands. So in this case, we multiply it by 4 to get us into 100. So 2 times 4 is 8. Now, the second way would actually be 2/25. I'm also doing a revision for WA. Now you know that fraction is also division. So 2/25 is the same as 2 divided by 25th. Right? So the second way is not useful in this question, but for WA1 purpose, we can just revise it. 2 on the inside, 25 on the outside. Alright, so this is also another way to get the decimal. So 8/100 is the same as 0.08. Now, if you are still unsure on how fractions is converted into decimals, you may want to very quickly draw a place value chart. Alright, to remind yourself, this is the tenth, this is the hundred, and this is 1,000. So when we say 800, that means 8 is in the 100th place. Alright, so that's how we ended up with 0.08. Alright, so for people, a few number of you in the class who actually were able to get 800 but were not able to successfully change into correct decimal. Alright, take note of this place value chart. I'm sure a lot of primary 4 teachers would have reminded you to do so. Question number 2, 8 million. So we revise on our place value again. We have the ones, tens, hundreds, thousands, 10,000s. We have the 100,000s. And after the 100,000s, we go into millions. So 7 digits for a million. This is 8 million. 340,000. 340,000. 16. So 16 is of course the last. So there's a blank in the middle, so we fill up with a 0. So this is 8340016. Alright, so you can see, even though question 1 and 2 look simple, there's a lot of workings involved to make sure that I get as many marks as possible. Which is why your seniors always find that paper 1 is a time rush, because there's a lot of things they need to do to get as many marks as possible. Alright, in order to recover the lost marks that can happen in paper 2. Question number 3. Alright, so this is splitting up into 8 and 100. So we could do the division this way with the 100 first, then with the 8. Alright, with the 100 it's easy. We cancel a pair each time, which will give us 560. 560 divided by 1 is 560, divided by 8. So when you do your long division, this is how it will look like, 56. Alright, when you bring down there's nothing, you still need to put a 0 on top. Alright, this is for people who have forgotten how to do your long division. The answer is 70. Okay, now just a reminder for your WA, make sure the workings are presented at the side. Okay, so in the event that your answer is wrong, the teachers can still go back to your workings to look for any possible method mark, which we call it as M1 all the time, method mark 1 mark. Alright, So that's it for page 1. Let me go on to page 2. Remember, you can pause the video. Alright, question number 4, let's do a cross multiply. So if you recall, when we did this, our friend actually discovered that there's a way to show how the cancellation method works. So 6 and 3 is a very good way to do a cancellation. Alright, so 6 and 3, we can divide both of them by 3. So 6 divided by 3, we get a 2. 6 divided by 3, 3 divided by 3, we will get a 1. So what we do have now is 2 times 2 is a smaller number. 7 times 1. 4, 7. Alright, now the wonders of cancellation method is you will definitely end up with the simplest form. Alright, a few of you in 5G, you realize that if you didn't do it by the cancellation method, this is what you did. 6 times 2, 7 times 3. Nothing wrong with it, it will still work. But the only problem is that you do not end up with the answer that is in the simplest form. And as a result, I had to mark you as wrong. Alright, comparing it to a person who did the cancellation method, you find that it arrives at the simplest form immediately. So that's the power of cancellation method. Alright, now in the WA, if you do not give your answer in the simplest form, answer mark will not be given. So please be very careful, especially for fraction that has double digit. You must ask yourself, is that the simplest form? Okay, question number 5. 324,089. So we want to express this, or rather we call it round this number to the nearest 1,000. So we locate where the 1,000 is. Now, whether this number will go up or remain the same depends on the number behind it. Right? So in this case, the number behind it is a 0. So our decision shall be to round back the number. We are not going to round up the number. So 4 will still be 4. The rest of the number will just be 0. Alright, so most of you were able to round this, which is very good. Now, question 6, you can almost be very sure that it will come out in your WA. So again, don't be greedy, serve one at a time. So we start off with the brackets first because they are the king. Alright, so we do not copy the whole question, we'll just continue from below. 36 is still 36. Alright, 4 plus 2 will be 6. Now the rest is just copy down. Alright, you don't serve them, you just copy down first. Now the next person that we're going to serve is the queen. Alright, the queen is the one on the left, not the one on the right, because from left to right we serve the left first. The kitchen is on the left. So 36 divided by 6 will give us 6 times 12 minus 5. The next person we're going to serve now is still the queen, right? But it's this queen now. 12 times 6, which is going to be 72. Minus 5, nobody else to serve. We serve our last prince or princess. Alright, so this is 67. Alright, as the answer. So a few of you actually arrived at 72, but when you subtract by 5, you subtracted wrongly. So please be very careful, because question 6 is a 2-mark question. Alright, so you either get it right or you get 0 if you calculate wrongly. Okay, that's for question number 6. Now question number 7 is a simple unitary method. So what is happening is this. You had this 320 grams of flour. You use 3/8 of it. Okay, this 8 refers to this amount. So 3/8 of it means the total unit is 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Now the 3/8 of it was actually used to bake some tarts. And the rest of it was actually used for muffins. Now the question would be, since the total is 320, right? They ask how much flour is used to bake the muffin, which is a question mark here. Okay, so by unitary method, 8 unit is the total units, right? 320. We find out what is 1 unit first. 320 divided by 8. If you can do mental sum, by all means. Alright, if not, do the division. You get 40. How much flour was used to bake the muffin? Now the muffin has a total of how many units? Let's see. 1, 2, 3, 4, 5, 6 units in total. So for us to find the muffins, we take 40 times 6. Alright, we will arrive at 240. Am I correct? 1, 2, 3, 4, 5. 1, 2, 3. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I know why. I shaded one box lesser for tarts. So the muffins will not be 6 units. It is 5 units only. Alright, so times 5 gets me 200. That's the final answer. Okay. Alright, now moving on to question number 8. Question number 8 is our favorite branching method because of the word remaining. Okay, now there are some cookies in a container. 3/4 are chocolate. So now look, this branch doesn't have any total to begin with. We do not know how much is the total cookies, right? But we know that 3/4 of it is chocolate. So let's label that. Now if 3/4 are chocolate, it will leave us with the rest, right? Let's call it remainder. You want to call it the rest, that's fine. Okay, so if you have 3/4, of course 1/4 is what's left. Now out of this remaining, let's branch out further. 1/3 of the remaining are blueberry. So meaning to say 1/3 is blueberry. The rest are vanilla. Now this is the rest. 1/3 is blue. That means 2/3 must be the rest, right? Which is vanilla. So question is, what fraction are blueberry? Alright, so with the highlighters ready, you are now ready to trace the branch that shows blueberry, right? So the blueberry is none other than this branch. Alright, we trace back to the roots over to here. So this is how the whole branch is for the blueberry. Now remember, the branch represents multiplication. So all we have to do is to take 1/4 times 1/3. And we will have the answer 112. Alright, so this is a simple branch where it arrives at your answer immediately. Alright, because it's only a single branch. Alright, just remember, branches means multiply. Okay, now jug A and jug B. So this is a question about equal ending. So you have jug A that contains 158 and jug B contains 496. So you are doing some kind of a transfer. Whatever you transfer, both must have an equal amount. So the idea is this. Okay, if you are going to transfer in between both of them, the thing is the juice will still be the same at the end of the day, the total. So why not find out what is the total of these two jugs first? Alright, now reason why I do that is because no matter how you pour, you still are dealing with 654 milliliters of juice, right? No matter how much you pour. But now because we want to make sure that they are equal amount, so since there's only 2 jugs, right? So we are going to try to divide it by 2 to see how much one jug should have. Because the total is 600, we divide it by 2, we get 300 something. Now we want to make sure that every jug has 327. That's the idea behind it. Now as of now, jug A only got 158. So for that to be equal, it needs to reach 327, right? So how much to pour? We will need to subtract. Alright, we will get 169 as the answer. Of course, some of you can argue, is there a different way? Sure, you take the other jug instead. taking the other jug will be 496 exceeded, right? So you want to make sure that the jug only has 327 to be fair, right? So that is another way you will also get 169. Alright, two different ways, same answer. Okay, question number 10. Oh, by the way, since we are at the last question of paper 1, this WA will be the same exact format as this milestone check paper. So paper 1 is 20 minutes. Alright, now 20 minutes, 10 questions. So you roughly estimate each question should take no longer than 2 minutes. That's how fast-paced paper 1 should be. Alright, to pace yourself, each question should be no more than 2 minutes. But of course, if the earlier questions you can do them faster, it leaves you more time. This is for the end of the paper. Alright, now bookshops are selling markers in packets of 5. Each packet is $7. So if you could remember, this is almost like a question about set. So you have got markers, 1, 2, 3, 4, 5 markers. Each packet is $7. Miss Chu has $30. Alright, so technically if you have $30, you should be able to buy how many packets at most? You can only buy up to 4 packets, right? Yeah, so because 7 times 4 is already 28. So 7 times 4 is already 28. You can't buy the 5th packet because that will exceed, right, the amount. So this 4 actually just means 4 sets of 5 markers. So how many markers is there in 4 sets of 5 markers? 4 sets of 5 marker, 20. So that's the answer for the question number 10. Okay, now I'm going to move on to question paper 2 now. So paper 1, that's the idea. Now your goal, of course, is to score as much points as you can for paper 1. Alright, so that it will leave you some chance for paper 2 later on. Alright, now I'm going to go on to paper 2, 30 marks paper. 3 girls collected plastic bottles for recycling. Jane collected 26, which was only half as much as Kelly. So Jane and Kelly, it looks like Kelly is the lousy one, right? Jane is the lousy one because Jane only collected 26, but it was only half of what Kelly has. So meaning to say, Kelly must be double lah. Alright, the opposite of half will be double or twice. So Kelly is better, right? Because Jane only collected half. Alright. Now the next question is this. Kelly collected 9 more than Larry. So it seems again, now when I try to compare Kelly and Larry, Kelly still seems to be the better one, right? Kelly still seems to be the better one because Kelly still won by how many? 9 more. So Larry must be lesser lah. Alright, so let's find out how much is Kelly first lah. Kelly is just twice, right? So we have 52. Okay, but because Larry is the lousy one, so 52 minus 9, Larry got lesser. We will have the answer 43. Now 43 stands for Larry. So you can write to tell yourself what this number means. 52 is for Kelly. Okay, 26 is who? Jane, right? So now the numbers all become very easy already. Kelly, Jane, Larry. So what do you do next? Because it's calculator, remember you have a calculator, so please don't do your workings anymore. Use the calculator this Friday. Don't get into such a big habit. You have workings and then you do the workings and waste time. So that is question number 1. Okay, now question number 2, I am going to use the model way. Alright, factory X and factory Y, they produce this amount of notebooks. So X and Y produce this amount of notebook. Now factory X, the next sentence I'm reading, factory X and Z produce 41,000. 41,000. Okay, now it seems that factory Y is quite a big factory. It's producing a lot, in fact 7 times as much as Z. So the other time in the video, I actually had challenged Ian to do a model method for this type of question. So here I am going to share a different way. Ian shared with me the model method. I'm going to share an easier way, all right, which is like that. Factory X and factory Y. All right, so factory X model will look like this. X is just X, all right, a box which you don't know how many. Now Y is the one that produces 7 times as many as Z. Y is the big factory, right? So I would like to show that Y is a very big factory, and in fact it is 7 times bigger. 1, 2, 3, 4, 5, 6, 7. So these are all factory Y. Okay, now the next sentence is this. Factory X and factory Z. Again, we have got X, the same X, so we draw the same box. You notice the X tallies, same box. Okay, X is the same X. But now, we are actually looking at factory Z, lousy factory. Alright, this factory only has got 1 time. Instead of the 7 times, this factory only got 1 time. Okay, now you can see very clearly now already, this total is 74018, whereas this total is only 41732. Now can you see something? All right, there is an extra box here, there's an extra box here, there's an extra box here, there's an extra box here, here and here. Now those that I shaded are actually the extra boxes that cause this number to be bigger than this number. Alright, one more time I repeat. This is an extra box. This is also an extra box, an extra box, an extra box, an extra box, an extra box. Now this extra boxes is what is causing this number to be bigger than this number. So what can I say? If I take the differences of the two, if I subtract the two big numbers, they will be able to tell me how much the 6 units are. Am I right? How do I get the 6 units? Because of the 6 extra units. So why not? Let me do a subtraction first. Let me find out the difference first. So I find out the difference. Again, and then this difference actually will refer to 6 units. Alright, because of these 6 extra units, the number was extra by 3,000 over. So in the exam, how do you tell if your answer is correct? When you use a calculator, you will find that, hey, it's a very nice number. No decimal. Alright, for 1 unit. Then usually you should be quite happy because you are getting on the right track. Okay, so this one box actually is just simply 5381. 5381. 5381. 5381. 5381. Alright, you may not want to write it all the time. I'm just showing you each unit is 5381. Okay, now the question is asking how much did factory X produce. Let's focus on this model, shall we? Alright, you already know part of it is 5381. Do you think you can find out what is Z? Right, you can simply take 41,000 minus away 5,000, right? That will give you the answer immediately. So the last step, 41,732 minus away the 1 unit, you will get the factory X amount, which is 36351. Alright, so this is the model method I was actually talking about. to challenge Ian and a few of others to look into how you can do this in a unitary method. Okay, now question number 3. Again, branching, because I see this word remaining again. Joe had some money, all right, but in this case, you definitely have no idea how much money is that, right? So you do not know the seed. Okay, now before we go on into question number 3, let me share with you your what is that? Your attendance code. All right, again, pause the video if you need to copy down the attendance code. So these are for first 10 register. Now, usually when I mark your attendance code, I will print out a copy so that I will be able to see at the side whether your code is copied correctly as well. Okay, this is for register 11 all the way to 20. Question register 11 to 20. Now next, go on. Register 21 to 30. And the last one is register 31. All right, so this is the attendance code. You can rewind, reverse, just to check your code again. Okay, now to make the video shorter, let me just go straight back into the question. Joe had some money. He used 1/5 of it. All right, so let's branch out already. Let's start the branch. Let's name it. This 1/5 is called the back. Now, if you have already spent one part out of the 5 parts on the back, this will leave you with 4 parts, right? And let's just call it remaining. Okay. Now let me read on the story. She spent 1/8 of the remaining on a present, on a birthday present. So we're going to continue the branch from remaining. So since this is the amount of money she's going to spend from the remaining, so the 1/8 is so-called the present that is being spent. Now this leaves us with 7/8, right? Which is you can call it remaining, you can call it the rest. Okay, now the next question is this. The back and the present cost $156. Now the back is none other than this branch. This is the first branch. Now the second branch is the present. Now where is the present? The present is here. Now trace back the branch, you will be able to see that this branch connects to this as well. All right, so let's try to solve the harder branch first, shall we? Now we have this branch here, 1/8. The branch is actually the same as multiply, right? 1/8 of the 4/5 remaining amount of money. Let's see how much is the present, okay? So we cancel. This is 1/10. So this is for the present. The actual present is 1/10 amount. And whereas for the back, now, because the denominator is in 10, right? So let's change the back into 10 also. Now it becomes 210. All right. So, cool. The back is 210. The present is 110. So the person actually spent a total of 310 on both presents. Did they say how much is that? That is $156, right? So put it simply, 3 units. Why is 3 units? Because this 3 represents 3 units. Okay, some people, if you remember, I also shared with you another way. 310 represents 156. You can do it this way also. Or you can do it by unitary method. Okay, 3 units is 156. Again, let's find 1 unit. Should be a nice number, which will be 156 divided by 3 is $52. How much money did he have at first? Now 10 units was the total denominator, right? So we just simply take 52 times 10. We will arrive at the answer 520. Okay, so this is a classic example where sometimes the branches, the total amount, this whole number, can refer to 2 total branches which you have to add up. All right, because there are 2 separate branches, add it up to get this whole 156. Alright, so very likely you will see this in WA as well, sometimes going up to 2 branches. Okay, not just one branch. Okay, question number 4. Now, question number 4, we kind of covered it in our MSP. So, what is going to happen is when it comes to age, alright, something very special about age is that the difference will never change. If I'm 20 years older than you, I will forever be 20 years older than you, no matter how many time flies. Okay, so let's take a look. This is about now, right? We want to look at the present now. About these two person, Pete and Jamie. Pete is 6 times. So let me draw out the 6 times. 1, 2, 3, 4, 5, 6. Jamie, of course, will be 1. 6 times versus 1 time. Now, do you know the total? Actually, you do not know. But they said this. In 5 years' time, their total age will be 73. Now, 5 years' time is in the future. It is not now. This is about the future. But if I want to see what is the present amount, that means now, total. Do you think there's a way to find out? In the future, there are 73, right? But 5 years later, there are 73 total. 5 years ago, they are supposed to be younger by 5 years. Another person should also be younger by 5 years. Am I right? Because we are talking about total age. So shouldn't we minus 5 twice? Because we are talking about both people, the total age. So let's minus 5, let's minus 5. We will go back to the present. So their total age now is just 63. Okay, so this is just 63. So if you do not believe, you can always work backwards. 63 plus 5. This person grow older by 5. Another person also grow older by 5. So 63 plus 5 plus 5 will get you back 73 again. Okay, so now we have it. We know that A is already solved. 63 is their total age now, not 5 years later, but now. Now their total age is younger. Okay, younger by 10 years. Now part B. How old will Pete be when he's 4 times as old as Jamie? Now let's take a look first. 63 refers to how many units first? 1 unit, 2 unit, 3 unit, 4 unit, 5 units, 6 units, 7 units. 7 unit gives a total of 63. Wow, it's a very nice number because I know 63 is in the 6 times table, right? Okay, 1 unit is 9. Now, why am I finding what is 1 unit? Because if I can do this, I will be able to know how much is their difference. 1, 2, 3, 4, 5 units. There are 5 units apart right now. Let's see how old are they different. 9 times 5. Now, do you know what is the meaning of 45? It means that no matter how many years have passed, there will always be one person older by the other person by 45. Okay, this gap will never change. 10 years later, I will still be older than you by 45 years. 20 years later, I'm still going to be older than you by 45 years. Right? Because you grow old, I also grow old. So part B will now be easy already. But Pete and Jamie, you want Pete to be 4 times older than Jamie. You want Pete to be 4 times older than Jamie. This is what you want, right? Part B, you want Pete to be 4 times older than Jamie. But you know that no matter what, their difference, which is the 3 unit, will always be 45. No matter how old, no matter how many years have passed, no matter how many times, whatever it is, I'm always older than you by 45 years. So right now, part B will be 3 units 45 already because our difference is 45, right? We found out earlier. 1 unit will be 15. So how old will Pete be? This will be 4 units. 15 times 4, which is 60. Alright, so Pete will be 60 basically when he's 4 times older, 4 units. Alright, now question number 5, our last question for paper 2. Okay, Now, question number 5, I would actually like to go back to this question on set. Now, you can almost be sure that there will be a question on set in your coming WA1. So I thought this is a very good question. I'm going to use set to revise. Now, I know in my answer key that I sent to your parents, I use the guess and check method. Now, in this video, I'm going to instead use the set method, which will be very useful for your WA1. Alright, now you have got a pie that's $3, so let's list out the numbers. A cake is 2 times as much, so a cake is got to be double, right? $6. Okay, now she bought 4 more cakes than pies. Now 4 more cakes than pies would mean this, if you have a set like this, you have a cake and a pie, you have many set of this, you can have another set of cake and pie. You will eventually have a situation where there is not enough pie, alright, because there is 4 extra cake to go with that does not belong to a set. So if you remember this, alright, we drew pictures in our MSP, right? Cake is $6, $6, $6, $6. But we know that the total is actually $150. That means this whole thing is $150. Okay, now a set of cake and pie, by the way, is $9. How do I get $9? Because 6 plus 3 is $9, right? Each set is $9. Now, it looks very nice. Each set is $9 extra value meal, right? $9, $9, $9, $9, $9, $9. But the problem is, there's this 4 extra cake that is not part of a set. So what we could do is, why not, alright, we try to take away all these extra cakes first, because these cakes couldn't form a set, right? Let's take away this $24 because they couldn't form a set. So if you take that away, now your total is no longer $150. It is only $126. Okay, now this $126 would actually mean this. Alright, what does it mean, $126? It means that I've taken away the cake, all the 4 cakes, and now the total is only $126. So now I have even number of set already. Each set is $9. I have $126, right? So I want to see, if each set is $9, I want to see how many set I can make with the $9. $9, $9, $9, $9, $9. Exactly how many $9 can I form? Okay, so this is actually 14. If you remember again MSP, this is 14 sets of 1 cake, 1 tart, or 1 pie. Okay, there are 14 sets of it. 1 cake, 1 pie, 1 cake, 1 pie, 1 cake, 1 pie, 1 cake, 1 pie. So how many pies did this person actually buy? Easy peasy, 14. Okay, because 14 sets will give you 14 pie, right? But what about cake? Cake got 4 extra cake, right? So 14 plus 4 lah. Okay, so the cake is used to solve for part B. Okay, if you know that there's 14 sets of cake and pie, there should be 14 cake also, right? Plus the 4 extra cake. So you have a total of 18 cakes. Alright, but that's not what they want. They want a total amount paid. Each cake is how much? $6. So by doing this, you will also be able to get the answer, $108. Okay, go and revise on your MSP1, especially on set, because it will be pretty useful. Sets usually come about in PSLE as well, alright, when it comes to putting 2 things into one set, okay, with a total amount of money. So that's it for the video. We'll see you back in the class. with your corrections done, your code's written.